Hello class, so in today's lecture we're going to talk about Solow-Swan, the economic growth model. So this is the general outline of this video: introduction, assumptions and fundamental equation, steady state equilibrium, implications and relevancy, conclusions, criticisms, convergence hypothesis. So under convergence we have absolute and conditional convergence, similarly the golden rule under Solow-Swan model, and the last but not the least, difference between Harrod-Domar and Solow-Swan model. Okay, now let's go to introduction. Solow-Swan model was developed independently by economists Robert Solow and Trevor Swan in 1956. That's why it is called Solow-Swan model, or simply SS model. SS model got Nobel Prize in the year 1987 because it provides the theoretical framework to analyze the factors behind the economic growth. And similarly, both of them developed their model as the alternative to Harrod-Domar or SD growth model under the same foundation. So SS model is a representative of neoclassical theory because it is based on Cobb-Douglas production functions and neoclassicist diminishing returns and marginal concept. So it is considered as a highly stable model which helps to bring stability in Harrod-Domar model. Similarly, SS model states that both capital and labor can be combined in various proportion, and the economy is always in a stable equilibrium. Unlike there is fixed proportion of capital and labor ratio in Harrod-Domar model, under SS model it states that there can be a various combination or various proportion of capital and labor ratio. That's why it is also one of the main difference between SS model and Harrod-Domar model. So before going to the assumptions of SS model, let's have a quick concept of SS model. So the gist of SS model or Solow-Swan model is, it states that the long-term economic growth depends on the improvement in technology and productivity. That means any economy, for the long-term economic growth, they should focus on technology and productivity. So these are the major findings of Solow-Swan model. So what about short run and long run? So under short run, both SS model and SD model emphasize the importance of investment for growth. That means for short run economic growth, investment and saving plays important role. They both agree, but under long run, SS model shows that the long-term growth relies on technology and productivity improvements for sustainability. And however, under SD model is criticized for being too simple by only focusing on the saving and investment and ignoring important factors like human skills and technology that are essential for long-lasting growth. Now let's go to the assumptions of SS model. Okay, there are altogether 9 assumptions and 6 equations. The first assumption is there are 2 factors, capital and labor, which are combined in various proportion. Here one thing you need to note is growth depends on output and output depends on production functions. So our model starts with the production functions. Here Y means output, K capital, T technology, L labor. But for simplicity, we will only take labor and capital, or we can use Cobb-Douglas production functions. But again, for simplicity, we will just take these simple functions. Here one thing you need to note is various proportion means that the economy can utilize different combination of capital and labor to produce the same level of output, but which is not possible in the SD model. So the SD model assumes that there is a fixed proportion of labor and capital, which is considered one of its main drawbacks. Now let's go to the second assumptions. The production function is well behaved. So this is the production functions. So when the production function is well behaved, then it has 2 properties or 2 conditions. So the first condition is MPK and MPL greater than 0. Here MPK and MPL means marginal product of capital and marginal product of labor. So in mathematics we say first partial derivative greater than 0. So in language we say positive marginal returns. So this means adding one more of an input, that is capital or labor, while holding the other constant will always increase the total output. So this means when you increase the input, definitely there will be increase in output. So the second condition is MPKK smaller than 0 and MPLL smaller than 0. So in mathematics it is called second order partial derivative smaller than 0. So in language we say diminishing marginal returns. So as you increase one input, the additional output you get from each extra unit of that input gets smaller and smaller. So in simple, we can say that when the production function is well behaved, then it applies two conditions. One is positive marginal returns and second is diminishing marginal returns. Okay, now let's go to the third assumption. The production function is linearly homogeneous and it exhibits constant returns to scale. Here, constant returns to scale means CRS, and CRS means when the inputs labor and capital increases by double, then output will also increase by double. So now let's go to the fourth assumption. The production function satisfies INADA condition. A marginal physical product of labor, that is MPPL and MPPK, lies in between 0 to infinity. So which means, let's suppose a firm is using labor and capital by very few units, and now again the firm is trying to increase the labor and capital by very few units again. Then what happens is, here let's suppose when the labor tends to 0 or capital tends to 0, this means when the firm is increasing the labor and capital inputs by very few units, then our production capacity will be increased by infinitely. So again here, when you have almost no labor and capital, the first bit of labor and capital is tremendously valuable or have more efficiency on output. And now let's understand what happens if a firm increases labor and capital by more units. Let's say here the firm increases labor and capital by more units or near to infinity, then our MPPL will be 0 or our MPPK will be 0. So this means when the labor or capital input is infinitely large, the total output is also very large, but the last unit of labor added contributes nothing new to that output. So here the production function satisfies INADA condition, where INADA condition which lies in between 0 to infinity. Here do not get confused. Under assumption number 2 we have well behaved production. So here well behaved means positive marginal returns and diminishing marginal returns, but under assumption number 4 it is INADA conditions, where INADA conditions tells about the extremeness of a function. Let's go to fifth assumption. Production function can be expressed in terms of capital and labor ratio. So this is the production function or the aggregate production functions. So as per the assumptions, now let's convert this production function into per labor head. So to get per labor head, let's divide by labor on both sides. Then we get for Y by L, and for K by L, and for L means L by L. So L and L cancel and we get 1. Again, for simplification, the function f is denoted by g, small g, and for K by L is represented by K asterisk. Here these are the main important notations of this model, so you have to remember here. So here K by L means K asterisk or capital labor ratio, and the whole function is represented by GK asterisk. That means instead of f we are just mentioning g, small g. So similarly here Y by L is represented by small y, where small y means per labor output or per capita income. So that means here Y means total output or total income, and here L means labor or populations. So when we divide, we get per capita income or per labor output. So again K by L means K asterisk and K asterisk means capital per labor. So equation 1 tells that output per labor depends upon capital per labor. Okay, under sixth assumption, saving is a fixed proportion of income or output. That means saving is a part of income and saving has some fixed proportion of income. So this is the saving function, and this is equation 2, where capital S is total saving amount, small s means saving rate or MPS, which lies in between 0 to 1, where Y means income. So be clear that our first equation was related to capital labor ratio and this second equation is related to saving functions. So now let's go to the seventh assumption. The economy is having some net investment in each period. Okay, here at first let's understand what is investment. Here investment means change in capital stock. Here capital stock means whenever there is increase in capital each year, it is due to the investment. So here I means investment, and investment is due to the change in capital stock. And whenever you take derivative with respect to time to any variable, then we can write dot. So here dot means with respect to time. So simply K dot means net investment with respect to time. But in our first equation we had K asterisk, which means capital labor ratio. Here another thing you need to note is net investment means after deducting the depreciation. Okay, now let's go to the eighth assumption. Here it states that technology and population are exogenous. That means they are determined by externally, where population is growing at a constant rate, that is growth rate of labor, which is denoted by lambda. So the labor growth rate is L dot by L, where L dot means change in population or change in labor with respect to time, and L means last year population or last year labor. So after computation we get growth rate of labor, where dl upon dt means change in labor with respect to time. So now let's go to the assumption number 9. So it states that economy attains equilibrium when investment and saving are equal. So here we know that S equals to I. So S is replaced from equation 2 and I is replaced from equation 3. So our final equation 5 is Sy equals to K dot with respect to time. So this is our equation 5. Okay, now by using all these assumptions and the equations, now we are going to derive the fundamental equations. So let's derive fundamental equations from capital labor ratio. As you already know that K asterisk means capital labor ratio. Again, by rearranging it, we get K equals to K asterisk times L, so which is equation 6. Since investment and labor are changing over the period, so again we need to differentiate the equation 6 with respect to time in order to examine the time path of capital labor ratio. So let's differentiate both sides with respect to t. We have dk upon dt. Here differentiation of k is dk upon dt, and for k asterisk times L we get dk asterisk times L by dt. So again we can expand this equation into the product rule. So by using product rule in our first side, we get k asterisk is coefficient. So here L is dl upon dt. Again for second part, labor is coefficient, and for k asterisk, which is dk asterisk by dt. So by using product rule we get this step. For simplifications, let's convert dk upon dt into k dot, and similarly for dl upon dt into L dot, and similarly for dk asterisk upon dt into k asterisk dot. So again from equation 5, let's substitute k dot into Sy. So we get these equations. Again let's divide this equation both sides by labor, then we get these equations. Now substituting this equation from equation 1 and 4, we get this step or these equations, and finally when we rearrange these equations we get the final equations, the equation 7, which is the fundamental equations of Solow-Swan model. In your competitive exam, if you are asked to derive the fundamental equations, then you have to go through all this process. Otherwise, just remember these final equations. And now let's go in details about the fundamental equations of this Solow-Swan model. Here the fundamental equations has 3 major components. Okay, let's go from the left hand side, where K asterisk dot, here K asterisk means capital labor ratio, and K asterisk dot means capital labor ratio with respect to time. So here K asterisk dot, it shows the changes in capital labor ratio over the time. So when K asterisk dot is greater than 0, this means the economy is getting richer. So this means in our right side, when these two components are subtracted, and if the K asterisk dot is greater than 0, then economy is getting richer and richer. But if K asterisk dot is smaller than 0, then the economy is getting poor. But what happens if K asterisk dot is equals to 0? Then the economy is in a steady state. So according to Solow-Swan, according to Solow-Swan, when there is no more changes in capital labor ratio over the period, over the time, then that's what we call steady state economy, or it's a long run equilibrium. Okay, now let's go to the second component of these fundamental equations. So again, let's further divide and study each variable of these components, where small s means saving rate, which is a part of income or output, and k asterisk means capital per labor, and gk asterisk means output per labor, or it is simply the individual production functions. And similarly, when we combine all these variables, then it becomes actual investment or inflow of new capital. This is what we call the actual investment. Now the last component of this equation is here k asterisk means capital per labor, and lambda means it is the sum of depreciation rate of capital goods and the population growth rate. So here lambda not only includes the population growth rate but also the depreciation rate of capital goods. So when we multiply k asterisk times lambda, then it is what we get required investment to offset the existing capital. So in summary, we can say that change in capital labor ratio is k asterisk dot, and for SG k asterisk we call it actual investment, and for k asterisk lambda we call it required investment. So this is the fundamental equations of SS model. Okay, now let's understand these fundamental equations with the help of figure, and let's understand how the economy attains automatic steady state equilibrium under this model. So this is the main equation, and in x-axis we have k asterisk, which means capital labor ratio or capital per labor, and in y-axis we have k asterisk dot. That means here in y-axis we can show per capita income and change in capital labor ratio. So this is the required investment k asterisk times lambda, so which begins from the origin and increases at a constant rate. So here k asterisk times lambda means required investment, which means the economy must invest in order to maintain its existing capital depreciation rate and increasing population growth rate. So this is the saving amount of an economy, where we know that saving equals to investment. That's why we call it actual investment amount. So when these two lines intersect, then we get the point E. So here the point E is called the steady state equilibrium. So at the point E we have this much amount of capital labor ratio. So this is the production function. So when we draw the line from the equilibrium point, then we get per capita income, or simply Y. So at point E the economy is in steady state equilibrium. Now let's suppose that we are at point A where actual investment is greater than required investment. That means the point A is the disequilibrium point. At point A, every labor are getting enough capital to produce goods and services. So economy automatically moves from point A to E as shown by the arrow. Okay, now let's have another situation. Let's suppose that we are at point B where required investment is greater than actual investment. This means the point is also the disequilibrium point. Here at point B, every labor are getting very less capital, which decreases the production level and output, and automatically it brings economy from point B to E as shown by the arrow. So this is how economy attains automatic steady state equilibrium under Solow-Swan model. Okay, now let's understand numerically. Here when actual investment and required investment are same, here 5 minus 5 is 0. So there is no change in capital labor ratio. So here 0 means the economy is in equilibrium. Similarly, when the actual investment is greater than required investment, then the economy is improving. That means the change in capital labor ratio is positive. This means our economy is growing. Similarly, when the actual investment is less than the required investment, that means our economy is decreasing. Here, when the change in capital labor ratio is negative, that means our economic growth rate is decreasing. So the economy is in equilibrium at point E with K0 asterisk capital labor ratio, in which both actual and required per capita investments are equal. So here this equilibrium is stable because if the existing capital labor ratio is below or above the equilibrium ratio K0 asterisk, then the sooner or later the economy attains equilibrium. Again, you can see here in written form. For example, if the ratio here K0 asterisk, this means K0 asterisk is smaller than K1 asterisk, which is actual per capita investment greater than required per capita investment. That means here the point A is actual per capita investment, which is greater than required per capita investment. So here the economy is investing more than is just needed to maintain the current capital per worker. The capital stock is growing faster than the workforce or depreciation rate. Hence, level of capital per worker K asterisk will increase, move right as indicated by the arrow. So this growth continues until it reaches to the K0 asterisk. Similarly, what happens if the ratio K0 asterisk greater than K2 asterisk, which is required per capita investment greater than actual per capita investment? The economy is not investing enough to replace the depreciating capital and increasing population. The required investment for maintenance is higher than the actual amount being saved and invested. The level of per capita worker K asterisk will decrease. That means it moves left as indicated by the arrow. This arrow. This shrinking continues until it reaches to K asterisk. So this was all about the explanation of this figure. Okay, now let's study the implications and relevancy of this model. This model helps to identify the determinants of economic growth. This model shows that what happens when there is change in saving rate, population growth rate, and in technological progress. So there are major three implications of this model. Implication of saving rate, implications or changes in population growth rate, implications of technology. So now let's go from implication of saving rate. This model suggests that increase in saving rate contributes to economic growth positively, and so there is role of financial market in mobilizing and promoting the saving rate. However, there is a limitation of this because saving rate cannot be increased more than one. This means saving is a part of income and saving never exceeds income. So again, let's understand this with the help of figure. In the given figure, initially the economy is in equilibrium at point E0 with S0 saving rate. Now let's suppose that our saving rate increases from S0 to S1 as shown in the figure. So when our saving rate increases from S0 to S1, it also increases the equilibrium point from E0 to E1. That means the saving rate has positive relationship with economic growth. So when the saving rate increases, it increases the economic growth and the steady state equilibrium as well, as you can see from the given arrow. So in written form, in the given figure, when the saving function shifts from S0 GK asterisk to S1 GK asterisk, it also increases capital level ratio from K0 asterisk to K1 asterisk, which is a short-term rise. So increased saving rate plays a positive role in the economic growth. So now let's go to the another implications. Implications are changes in population growth rate. Increase in population growth rate at a given saving rate leads to fall in capital per labor, and which increases unemployment as well. So let's see from the figure. In the given figure, initially the economy is in equilibrium at point E0 and the population growth rate is K0 asterisk lambda. So let's suppose when the population growth rate rises from K0 asterisk lambda to K1 asterisk lambda, keeping saving rate constant, then the equilibrium point or the steady state point shifts leftward from E0 to E1. That means there is a negative relationship between population growth rate and economic growth rate. So in simple words, in the given figure, when the population increases from K0 asterisk lambda to K1 asterisk lambda, then it leads to fall in capital per labor and the per capita income. So now let's go to the implications of technology. The major implications of this model is to show the role of technology in the economy. The technology is assumed to be the exogenous and ultimate source of economic growth. Now let's understand with the help of figure. Initially, the economy is in equilibrium at point E0 with production function Y0 and saving rate S0. Now let's suppose that there is improvement in technology. So we know that with the improvement in technology, it increases the total output. So our output level increases from Y0 to Y1. And again, we know that with the increase in production function or production level, it will also increases the saving rate from S0 to S1. So with the increase in production level, it also increases the steady state or equilibrium from E0 to E1. That means the technology has the positive relationship with economic growth rate. So in written form, let's say there is increase in technology. With the technological advancement, it increases the production level from Y0 to Y1, which ultimately increases saving rate from S0 to S1 as well. So ultimately it shifts steady state from E0 to E1 equilibrium. So there are limitations of other determinants such as saving rate, labor growth rate, but technology has unbinding potentialities for economic growth rate. So in conclusion, technology progress is the major determinants of long-term growth rate. Instability is not the problem of the economy. There are limitations of other determinants such as saving rate, labor supply growth rate, but technology has unbinding potentialities for economic growth. Okay, now let's go to the criticisms of this model. A fundamental weakness of this model is its ignorance on the endogenous technology, both theoretically and empirically. It is criticized that technology can improve endogenously as shown by the new classical or endogenous growth model. Okay, next point. This model is unable to explain growth differential across the countries despite they do have same growth parameters such as labor supply or saving rate. According to this model, the countries with same growth parameters should grow at the same rate ultimately, but the different countries are growing at a different rates despite the same growth parameters. And another point is, this model argues that in long run, the economy is growing at a constant rate or at a stationary state equilibrium, but the empirical result or data shows that the country may have different growth rates, and so at the long run equilibrium, the economic growth rate may not be constant. For this model, increasing growth rate is possible only if there is improvement in exogenous technology. Otherwise, there is constant returns to scale. However, most of the developed countries realized increasing returns to scale over the period despite the change in exogenous technology. The situation of the developed countries cannot be explained by this model. And the last point is neglect of institutional factors. The model does not consider the role of institutions, governance, or political factors that can significantly impact the economic growth. Okay, now let's go to our seventh topic, convergence hypothesis. Here, convergence means to catch up. That means in long run, how the developing economy will catch up to the developed economy in terms of per capita income or in standard of living. So under SS model, the convergence hypothesis suggests that poorer economics will tend to grow at a faster rates than the richer economics, leading to a reduction in income disparities over time. The convergence hypothesis is the idea that over time, poorer countries will grow at a faster rate than richer countries, allowing them to catch up in terms of income and economic development. Essentially, it suggests that given similar conditions and policies, the economic gap between rich and poor countries will narrow, leading them to reach similar levels of wealth and prosperity. So now let's go to our another topic of convergence. Types of convergence. So basically there are two types of convergence. Absolute convergence. Here absolute convergence suggests that all economics will eventually converge to the same steady state level of income per capita regardless of their initial conditions. This assumes that all the economics have the same saving rate, population growth rate, and technology. So now let's go to the conditional convergence. It suggests that economics will converge to their own steady state level of income per capita, which is influenced by factors such as saving rate, population growth rate, and investment in human capital. This means that economics with a similar structural characteristics will converge, while those with the different characteristics may not. So this is all about the convergence hypothesis. Okay, now let's go to our second last heading, golden rule. Golden rule saving rate. Golden rule saving rate under SS model concept was developed by economist Edmund Phillips in 1961. The golden rule under the Solow-Swan model is the ideal level of saving that allows an economy to achieve the highest possible level of consumption per person in the long run. So in short, it is the saving rate that maximizes long-term well-being. So imagine a country has to decide how much of its yearly output to consume and how much to save or invest to build more capital like factories and machines. So then we have three conditions. The first condition is too little saving. So what happens when there is too little saving? There will be low investment. So low investment leads to low capital and low output. Similarly, the second condition is too much saving. So when there is too much saving, what happens? There will be high investment. So the high investment leads to high capital but zero consumption at present. So the balance or the golden rule is the balancing saving, the balance saving. So the saving rate that provides the highest sustainable level of consumption for all the generations. So in summary, you can say that the golden rule is the perfect middle ground. It's the level of saving where the extra output generated by new capital is just enough to cover the cost of keeping that capital in place. That means for replacing old and worn out machinery and equipping new workers. So any saving rate higher or lower than the golden rule will result in permanently lower level of consumption per person. So this was all about the golden rule. Okay, now let's go to our last topic, the difference between Solow-Swan and the Harrod-Domar model. So on the basis of foundation, SD model is based on Keynesian multiplier concept and the classical's accelerator concept. Similarly, under SS model is based on neoclassical, that is it used Cobb-Douglas production functions. Similarly, on the basis of goal, SD model is to find the growth rate to maintain equilibrium of the economy, that is aggregate demand equals to aggregate supply. So under SS model, the goal is to find the capital labor ratio to maintain the equilibrium. Capital and labor ratio are combined in fixed proportion under SD model, whereas in SS model, capital and labor are combined in various proportion. Similarly, the nature of equilibrium under SD model, there is knife edge or highly unstable equilibrium, whereas under SS model, stationary state and stable equilibrium. So the fifth difference is relative uses or importance. So the SD model is generally used in developing countries where there is shortage of data and informations, whereas SS model requires more disaggregated data and mostly used in developed economy. So the fundamental equation under SD model is S5V, where S is saving rate and V is capital output ratio. And under SS model, it depends upon actual investment minus required investment. Technology is constant in SD model, where technology is exogenously determined under SS model, and long-term growth rate depend on saving rate and investment in SD model, whereas in SS model, long-term growth rate is drives or depends upon technological progress. Similarly, the role of saving is critical for determining growth in SD model, whereas in SS model, role of saving affects only in short-term growth but not in long-term growth rate. And the last one is under SD model, it does not predict convergence, whereas SS model predicts convergence of poorer and richer economics. So that's it. Thank you. Any comments?